So for 5 factorial, right, what we were doing was we were calculating 5 factorial, and that would recursively calculate 4 factorial, which would recursively calculate 3, which would recursively calculate 2 factorial, which would recursively calculate 1 factorial, right? Now, something else is happening entirely here when we are doing the Fibonacci sequence and their calculations. All right? It is, if we are calculating the 5th Fibonacci number, we just don't do 1 recursive call. We're doing 2 recursive calls. To calculate the 5th Fibonacci number, I need to calculate the 4th Fibonacci number, but also the 3rd Fibonacci number, right? But wait, there's more. To calculate the 4th, I have to calculate the 3rd and the 2nd. And to calculate the 3rd, I have to calculate the 2nd and the 1st, right? That's all I need. But by the way, if I calculate the 3rd Fibonacci number, I don't, I'm going to calculate it here and then recalculate it over here. So this will also have to calculate, fib of 2 and fib of 1. So if I were to try to calculate the 6th Fibonacci number, by the way, right, fib of 6, it would have to recalculate the entire branch over here, and so on and so forth, right? I'm not going to bother redrawing out the 4th branch. So what's going on here that makes it different is that when we calculate, we do not 1, but 2 recursive calls that are completely independent of one another. Okay? These 2 recursive calls are completely independent, right? So I have this left branch, I have this right branch, and when I calculate over here the 3rd Fibonacci number, I have to recalculate it over here as well, right? Basically, I'm redoing work because I can't communicate to this branch over here that there is, that we've got that we're doing a bunch of the same calculations over and over again, right? We're recalculating the same numbers over and over again. So what is the big O runtime of this? Yes?
Isn't it like the Fibonacci number?
Sorry?
I don't know. I was looking at the measurements, and as I went up to 40 and 45 seconds, 46 seconds, it started following a Fibonacci sequence almost in terms of.
So for the Fibonacci sequence, how quickly do things grow? Is the question. So interesting observation. How quickly do things grow with the Fibonacci sequence? So what's the difference here comparing these numbers? The Fibonacci sequence itself, the numbers one to the next one, very closely almost double. So yes?
Doesn't it grow factorial?
Factorial would be worse than as it goes. It actually does slightly better than factorial time. Yes?
Well, because you split things into
yes.
2, it needs to be a power of
2. Yes. It is a big O, 2 to the n. And in fact, if you try it out, right, if you're able to try it out by calculating the 49th number, and that will take a while. And then if you try to do the 48th number, it will take about half the amount of time. And then if you do the 50th number, that'll take twice as much time as the 49th. Because what does 2 to the nth mean? It means an additional n, an additional input, will double the amount of work we have to do, right? And that makes sense, right? To calculate fib of 6, to go from fib of 5 to fib of 6, I had to create a second branch that's almost as big as this other branch. And as we get bigger and bigger and bigger, right, to the point that we're at the 50, at a size 50, Fibonacci, let's call it tree, the sides of the tree are about the same size. So you have 2 to the n. All right, so that's the Fibonacci sequence. All right, so with that, we're going to move on to fun and games. All right? So go ahead and upload what you have. That's a preview, and we're going to do this again, but now we're going to do it with something a bit more fun.